Okay, let's look at our test review over differentiation rules. Here, question number 1, we've got 9 times the cube root of x squared, and we want to find f prime of 8. So I need to find the derivative of this function, and whenever I see a root, anytime we have a root, we need to rewrite that as a fraction exponent. So I've got the cube root of x squared. That's going to be the same thing as x to the 2/3. Now that I have this rewritten, I can see that all I need to do is apply the power rule here. That 9 being multiplied in the front, it can just stay there and multiply by our derivative. So f prime is going to equal 9 times 2/3. The 2/3 is going to multiply by the 9. And then we're going to subtract 1 from 2/3. And 2/3 minus 1 is negative 1/3. Now I need to substitute 8 into this, but I'm going to do some simplifying first before I substitute that 8 in. 9 times 2/3, that's 18 divided by 3, or 6. And then I have x to the negative 1/3. The negative part of the exponent means that my x needs to go to the denominator. The 1/3 part of the exponent means that we're going to cube root the x. So I've got 6 over the cube root of x. And now I'm going to substitute in 8. F prime of 8 is going to equal 6 divided by the cube root of 8. And the cube root of 8 is 2. And 6 divided by 2 is 3. Answer A. All right, question number 2. Here we've got y is equal to tangent x minus cotangent x, find the derivative. So just straight, simple, do you know your trig derivative rules? Well, the derivative of tangent is secant squared x minus the derivative of cotangent, which is negative cosecant squared x. And so I have secant squared minus negative cosecant squared, or secant squared x plus cosecant squared x, and that corresponds again to answer A. Next question. When I look at this question, what I hope happens is that you look at that and say, oh, well, that looks like the limit definition of a derivative. And I know that because I see this little plus h here in the parentheses. I've got a limit as h is going to 0. So this is just a really fancy way of saying find the derivative of f of x. And so if I look at this, I can see that my function here is cosine x. So I'm going to find that derivative. The derivative of cosine is negative sine. And then I want the value of the derivative at pi over 2. The pi over 2 means that I want to find the value of the derivative of cosine at pi over 2. So negative sine of pi over 2 is equal to negative 1. Sine of pi over 2 is 1, and so we get negative 1, answer E. All right, next question. F of x is equal to x, then f prime of 5 equals what? Well, if f of x equals x, then f prime is 1. F of x equal to x, that's just a linear function whose slope is 1. And the slope is always 1, regardless of what x value you're at. And so f prime of 5 is going to be 1. F prime of 2 would be 1. F prime of negative 23 would be 1. Any x value that we plug in there, the slope is still going to be 1. All right, question number 5. Ask us to find the derivative of 1 over x cubed minus 1 over x plus x squared at x equals negative 1. All right, so here I see some rational expressions for my variables in the denominator, and I need to rewrite that before I can find the derivative. So 1 over x cubed, I can rewrite as x to the negative 3, minus 1 over x is x to the negative 1, and then x squared does not need to be rewritten. Now I'm ready to find the derivative. My derivative would be negative 3x to the negative 4. Negative 3 minus 1 is negative 4. And the negative 1 times the minus x, that minus becomes plus x to the negative 2. And then my final term derivative is 2x. Now I need to substitute in negative 1, but I'm going to rewrite these negative exponents before I substitute in the negative 1 because I think that'll make a little more sense. And I'm sorry if you hear that noise. That's my little dog Hermano running back into the room. So let's rewrite. I've got negative 3. And then the negative exponent means that my x needs to go in the denominator, x to the 4th. Plus, I've got x to the negative 2, so that x is going to go in the denominator as well. And I'm just going to put a 1 here in the numerator. And then, of course, 2x does not need to be rewritten. Now I'm ready to substitute in negative 1. So I have negative 3 over negative 1 to the 4th. Plus 1 over negative 1 squared plus 2 times negative 1. And of course that negative 1 to the 4th, that 4th power makes it positive, but I still have a negative 3 on the top, so negative 3 plus negative 1 squared becomes positive, and so that just stays positive 1. And then 2 times negative 1 would be minus 2. So negative 3 plus 1 minus 2 equals negative 4, answer D. All right, moving on to question number 6. Here on question number 6, I have e to the 3 times natural log of x squared power. Now, a lot of you, when we were working on the review, you did a chain rule here, which is certainly appropriate. We do have a chain. In fact, I've got 3 different functions here being composed together, and so the chain rule is appropriate. However, whenever we see a natural log, it's always a good idea to think about log properties and can I make this simpler before I do a derivative. So I'm going to rewrite the function down here, 3 natural log of x squared. Now notice here I've got e raised to the natural log power, and that can cancel out if they're right next to each other. I've got to do something with that 3 before I can cancel them out. So I'm going to use my log property, and I'm going to move that 3 to make it an exponent on the term here that's being logged. And now I have e to the natural log, and those undo each other because they're inverse operations. And so I'm just left with x squared cubed, which is x to the 6th. Multiply those exponents. So now I have a really simple function. This is my f of x, and so f prime is just going to be 6x to the 5th, which is, I cut it off on my graphic here, but that is answer E over there, 6x to the 5th, answer E for number 6. All right, on number 7, we want to find the derivative of u times v over w. Now notice I said u times v over w. That means in the numerator here, I've got a product, u times v. But overall, we're dividing, we have a quotient. And so I need to use the quotient rule as well as the product rule. So my derivative is going to be equal to, actually, let me back up. Let me write out our 2 rules here just to remind us. Derivative of f over g is equal to g f prime minus f times g prime over g squared. And the product rule, the derivative of f times g is f g prime plus g times f prime. All right, so let's start working on our derivative. For the quotient rule, we're going to start out with g times f prime, and the g, that's the denominator, which is w times f prime. Now f is equal to u times v, so here's where I have to do the quotient rule. I'm sorry, not the quotient rule, the product rule. And for my product, whoa, I don't know what just happened. Let me undo, redo. Oh, I just went to the next page. Sorry about that. Okay, back to F, which is U times V. And so in U times V, the U is, if I have U times V, then the U is my F and the V is my G. So I'm going to do F times G prime plus G times F prime. And all of that together is the F prime in my quotient rule. So I've done G, F prime, so now I'm at minus F, which is U times V, times G prime, which would be W prime, and all of that over W squared. And if I look at my answer choices, I don't see anything with parentheses, anything that matches this exactly, so it looks like I need to distribute this W to the parentheses. So I'm going to have U V prime W plus U prime V W minus U V W prime all over W squared. And it looks like that version of the answer corresponds to answer choice E. All right, question number 8. Here we've got f of x is equal to 2x minus 1 to the 5th power times x plus 1. Which of the following is the equation for the line tangent to the graph where x equals 1? All right, so we're writing an equation of a tangent line. And so I'm going to write down that formula right here. Y is equal to f of a plus f prime of a times x minus a. And in this case, my a value, a equals 1. So first of all, I need to find f of a. And so that means I'm going to take the 1 and substitute it into f of x. So f of 1 would be equal to 2 times 1 minus 1 to the 5th times 1 plus 1. And that would be 1 to the 5th, or just 1, times 2, which is 2. So my f of a is 2. Now I need to find f prime of a, which means I need to find f prime. Now if I look at my function, I have a product. 2x plus 1 to the 5th is being multiplied times x plus 1, so I'm certainly going to use the product rule. However, the 2x minus 1 to the 5th, this part here, that is a chain. 2x minus 1 is a function, and then raising it to the 5th power, that's a separate function. And so this is f times g, so I'm going to do the product rule, but when I find f prime, I'm going to have to use the chain rule. So here we go. So the derivative of my function is equal to f times g prime, and the derivative of g is just 1, plus g times f prime. So for f, I'm going to do a chain rule. Let's get our chart here. I've got two functions, something to the 5th power, and that something is 2x minus 1. So I'm going to do 5 times something to the 4th, and then the derivative of 2x minus 1 is just 2. So this is equal to 2x minus 1 to the 5th times 1 plus x plus 1 times 5 times something, that something is 2x minus 1 to the 4th times 2. All right, so there's my derivative. And I need to know the value of the derivative at 1 because that's my a value, f prime at 1. So I'm going to do 2 times 1 minus 1 to the 5th times 1. I don't need to write that again. Plus 1 plus 1 times 5 times 2 times 1 minus 1 to the 4th times 2. All right, so let's work this out. First parentheses here, 2 times 1 is 2, minus 1 is 1, and 1 to the 5th is just 1. Plus, 1 plus 1 is 2. And we've got to be really careful with this term here. We're going to do what's inside the parentheses first. 2 times 1 is 2, minus 1 is 1. And then we're going to raise the 1 to the 4th power. That 4th power is not for the 5. It is only for what we get inside the parentheses. So 1 to the 4th is still just 1 times 5 would be 5 times 2. And so if I multiply those together, let's see, 2 times 5 times 2 would be 20 plus 1. This whole thing equals 21. So now I have everything that I need to write the equation of my tangent line. So I'm going to sub into that equation. Looks like I may run out of room on my screen here. So y equals f of a, and we figured out that f of a was 2, plus f prime of a, which is 21, times x minus 1. Now, unfortunately, none of my answer choices are in that form, and so I need to do a little simplifying here. Again, be very careful. Don't add the 2 and the 21 together. That 21 needs to be multiplied into this parentheses. Y equals 2 plus 21x minus 21. And if I combine the 2 and the minus 21, I finally get for an answer y equals 21x minus 19. And that does correspond to answer B. All right, question number 9. Here on number 9, we've got a table of values for f, f prime, g, and g prime. They tell us that h is equal to f of x divided by g of x, and we want to find h prime at 2. So first thing I need to do is find h prime. And if h is f divided by g, well then I know that h prime is going to be g times f prime minus f times g prime over g squared. That's just the quotient rule. And wow, all of a sudden I'm writing really big. Sorry about that. And so I want h prime of 2. And so that's going to be equal to g of 2 times f prime of 2 minus f of 2 times g prime of 2, all divided by g of 2 squared, which is equal to, let's see, g of 2 is 3 times f prime of 2, which is negative 3, minus f of 2, which is 1, times g prime of 2, which is negative 2, all divided by g of 2, which is 3 squared. So 3 times negative 3 is negative 9. Negative 1 times negative 2, that's plus 2 over 9. And we get an answer of negative 7 over 9. Negative 7/9. And that corresponds to answer C. All right, last question. This question looks at a piecewise function and gets into the concepts of continuity and differentiability. First thing we're going to do here is sketch a graph of this function. 2 minus x for x less than or equal to 1. So if I plug 1 in, sorry, there goes our mono again. If I plug 1 into that function, 2 minus 1 is 1. So I'm going to be here at 1. I know that's where my graph is going to stop. I want to just graph this for all the x's less than 1. And that's just a line that crosses the y-axis at 2 and has a slope of negative 1. So it looks something like this. All right, then I'm going to graph x squared starting at 1 and graphing it for all x's greater than 1. Well, if I plug 1 into that, 1 squared is 1, so I've got the same point here, 1, 1. But my parabola is going to go from there. It's going to go up through 2, 4. I'll mark that point. And there's our parabola. So here's the graph of our piecewise function. And question B says find f prime of -1. Find the derivative at -1. And we could do that from the graph, and you can look at the graph and find that derivative or that slope. But I'm going to go ahead and find f prime. F prime is going to be equal to the derivative of 2 minus x, that's -1, and that's for all x less than or equal to 1. And then the derivative of x squared, of course, is 2x, and that's going to be true for all x greater than 1. So if I want f prime of -1, that means that I'm looking at this first, the top piece, the first piece of my piecewise function, and that derivative is equal to -1 always. For every value of x less than or equal to 1, the derivative is -1. To find f prime of 3, well, 3 is included in the second piece, and 2 times 3 is equal to 6. Let me show that step. 2 times 3, and that equals 6. So then we have the question, is f of x continuous at x equals 1? Well, yes, it is, because I plugged 1 into both pieces and got an output of 1 from both pieces. And so they do connect. They are continuous, and you can see that on the graph. Question E asks us to sketch the derivative. So I'm going to do that. Let's see, the derivative of the first piece was -1. And that includes the point at 1. So that derivative looks like this, just a constant function at -1. The derivative of the second piece is 2x, and that starts at 1. So if I'm at 1, then my derivative would be 2. And that's going to be a line with a slope of 2. So the derivative looks something like this. Let me see if I can make that line straight. Okay. So there's our derivative. And then the question asks, is the function differentiable at x equals 1? There's a lot of ways that we can arrive at an answer to this question. If I look up at my, sorry about that, I keep hitting the next page button. If I look up at my graph at x equals 1 right here, I obviously have a sharp turn. And so we know that means no derivative. If I look at the graph of my derivative, you can see right here that the derivative graph is not continuous at 1. That indicates that there's no derivative. The other way that I can determine algebraically is to substitute 1 into both pieces of the derivative. If I find the limit of the derivative as x approaches 1 from the left, that means approaching from less than 1. And we saw that that derivative is always equal to -1, regardless of what x value you're plugging in. And then if I'm approaching 1 from the right on f prime, well, that means I'm going to plug in to the 2x. My derivative on that side is 2x, and 2 times 1 is equal to 2. So you can see that these two values are different, and therefore it is not differentiable. And that brings us to the end of our test review.